to Flawless Mathematics. Today I will discuss operation on matrices. So yesterday I have discussed about what is matrix, what is order of matrix, and types of matrix. So first of all, first operation on matrices. First one is addition of matrices. So what is addition of matrices? Suppose there are two matrices, capital A 1, 2, 3, 4, and capital B, that is 5, 6, 7, 8. So there's some condition on addition of matrices, right? So first condition is A and B must be to same order. Okay, same order matrix. Suppose here A is 2 cross 2 matrix, but B is 2 cross 3 matrix. So addition of matrices is not possible in this case. Okay, so first condition of addition of matrices is same order. A and B must be of same order of matrix, right? So this is 2 cross 2 and A also 2 cross 2. So here addition of matrices of A and B is possible. And what is the resultant matrix? A plus B equals to 1 plus 5, then 2 plus 6, 3 plus 7, and 4 plus 8, right? 4 plus 8. So the resultant matrix, if we let us name it as C, so C equals to 6, 8, 10 and 12, right? So this is very easy addition of matrices. And in your book there are one example, factory at A and factory at B, and there's some information about Fatima has two factories at places A and B. See, and each factory produces sports shoes for boys and girls in 3 different price categories labeled 1, 2 and 3. So suppose Fatima wants to know the total production of sports shoes in each price category. Now the total production in category 1, this is for boys 80 plus 90, 80 plus 90, and for girls it is 60 plus 50. Then in category 2, for boys 75 plus 70, and for girls 65 plus 55. In category 3, for boys 90 plus 75, and for girls 85 plus 75. So this is the matrix. Okay, this is the matrix, and this is sum of the two matrices for boys and girls, right? For boys, this row is for boys, and this column is for boys, and this column is for girls. And this is factory number 1, factory 2, and factory 3, different category, right? 2 factories plus A and B. So for factory A, as we have seen already, for factory A 1 matrix is given, and for factory at B 1 matrix is given. And now we add these 2 matrix using the rule of addition of matrices. Okay, so basically what is the rule here? The rule is just adding the corresponding elements of the given matrices. Okay, how can you obtain the addition of matrix? So the sum of the 2 matrices is a matrix obtained by adding the corresponding elements of the 2 given matrices. Okay, now next is okay, here's example 6. You can easily handled it. Now next is multiplication of a matrix by a scalar. If we multiply a matrix with a scalar, so what would be the resultant matrix? Okay, suppose for previous quantities or example, factory A produced by factory A where 1, 2, okay, let me write it down. So for this is for boys and this is for girls. So 80, 75, 90, then this is 60, 65 and 85, right? Now suppose revised quantity produced by factory A are given as follows, that is double, right? So here scalar is 2 because we the matrix will be 2 into 80 into 2 into 60, 2 into 75, 2 into 65, 2 into 90, 2 into 85, right? So this is the revised quantity. So how can we get this new matrix? So just simply we multiply the each element of the previous matrix by 2, right? So we obtain this new matrix by multiplying each element of the previous matrix by 2. So in general, how may we write it? So in general, in other words, if A is a matrix, suppose the element of A matrix is Aij and this is a M cross N matrix, and we want to multiply a scalar with this matrix. Suppose the scalar is K and then K A is another matrix which is obtained by K into Aij M cross N. Okay, order of Ka matrix is also M cross N matrix order, right? So how can we get it? Just simply multiply each element of A matrix by the scalar, right? Now move to the next point. So move to the next point. Okay, before that there is an example 7. See, here is the example. So how what is says the problem? The problem says that A is a matrix and B is a matrix, and find out 2A minus B. It is very easy. What is A matrix here? So 2A minus B. So 2 into what is A matrix? It is given 2 1 2 3, then 2 3 1 minus B. So B is 3 minus 1 3, then minus 1 0 and 2. Just simply multiply these 2 of every element with every element. So 2 4 and 6, then it's also 4 6 and 2, plus adding you can take it minus here, or you can also minus multiply minus in the with the B matrix. So minus 3 plus 1 minus 3 and 1 0 and minus 2. So here's the result. This is minus 1 5 3, then 5 6 and 0. Okay, so let's properties of matrix addition. Okay, next point is properties of matrix addition. So the addition of matrices satisfy the following properties. What are the properties here? So first property is commutative law. Commutative law, right? So what is commutative law? The first property of addition is commutative law, right? So what is commutative law? If suppose A and B, two matrices of same order, right? This is also M cross N and this is also M cross N. They are two different matrices named as A and another one is B. Okay, now if we added A plus B, we got a resultant matrix. Suppose let us name it as C, and the order of C matrix is, you know, M cross N, right? This is M cross N, this is also M cross N, so C is also M by N matrix. Suppose your friend added B plus A, so and C got the answer or the matrix, that is capital D, that is also B cross N. So what commutative law is say? That C and D is the same, right? This is also M cross N and this is also M cross N, and C is equal to D. That is commutative law. Okay. Now next property is associative law. Next property is associative law. Associative law. What it says? The associative law is nothing but, it's also very easy. There are suppose three matrices A, B and capital C. So these are the three matrices, and here if you add A plus B, then with this resultant matrix you add plus C, you got a result. And in another way, if you multiply addition, so A plus then B plus C, with the resultant matrix of B plus C we add A matrix. So these two are also equal, these two matrices also equal. That is the associative law, right? Okay, there's a little task for you. Just get 3 matrices by your own choice, okay, and then get the result. Okay, see the result, that this 2 if you add the 2 different ways, you can see that it is same. Okay, so this is associative law. Now the third one is existence of additive identity. The third property is existence of additive identity, right? So let A is a M cross N matrix, okay, and O be the M cross N zero matrix. What is zero matrix? You already know it. In the previous lecture I have discussed about zero matrix. What is zero matrix? If all the elements are 0, then it is called a zero matrix. Okay, this is a 2 cross 2 zero matrix. Now what the property says? The property says that if A is a matrix of N cross N matrix and 0 be an M cross N matrix, then A plus 0, or you can say here O, because we name it as O. So A plus O equals to O plus A, and it is equals to A, right? In other words, O is the additive identity for matrix addition, because we already know that if you add any number with 0, you get the same number, right? So it is very simple, it's a basic logic actually. Now next property of matrix of addition is the existence of additive inverse, right? So the existence of additive inverse, what it says? So it says that if A be any matrix, then we have another matrix, that is minus A equals to minus, suppose elements are Aij, this is also a M cross N matrix, then minus Aij, this is also an M cross matrix, such that A plus minus A matrix equals to a O, that is 0 matrix. So minus A is additive inverse of A or negative of A. Okay, so if there exists capital A or A matrix, there also exists a additive inverse of that matrix, and if we add that 2 matrix, you will get a 0 matrix. Okay, now next is properties of scalar multiplication of a matrix. Okay, see, number 1 is K, this is a scalar into A plus B. Okay, K into A plus B. What it give us? So what it KA plus KB. Okay, here K is a scalar quantity. And what is B, A and B here? So A and B are the matrices quantity. Okay, then number 2 is if K, okay, K plus L into A, so this is also K plus L into Aij. That is, first you add this to scalar quantity and then multiply it with every element of the given matrix capital A. Okay, Okay, let us take the example 8 or 9. Okay, let us take example 9. Okay, example 9. Find x and y if it is given x plus y and it is given x minus y. So now you have to find x and y. So x plus y and x minus y. If we add these two, we got this is 5, 2, 0 and 9, then plus x minus y is 3, 6, 0 and minus 1. Okay. Now this, if we expand this side, okay, let me clear this. Okay, so if we expand this side, we got x plus x plus y minus x, right? Sorry, y minus y. This equals to 2x equals to 2 into x. So 8, 8, 0, 8, right? Okay, here 2 is not there because we add this 2. So 5 plus 3 is 8, 2 plus 6 is 8, 0 plus this is 0, so 0 plus 0 is 0 and 9 minus 1 is 8. So 2x equals to 8. So we can easily say that x equals to 4, 4, 0, 4. Okay, so we already find the value or the x matrix, right? Now for y matrix also x plus y minus x minus y. So if we expand this side, this gives us 2y. Now this equals to 2 minus 4, 0 and 10. So y is 1 minus 2, 0 and 5. That's it. Okay, that's it. Now move to the next slide. Okay, so there's example 10. This is also very easy. Okay, so okay, let homework example 11, 10 and 8. Do it by yourself. Just try it by yourself, then you will check with your book. Okay, so okay, that's it about today's class. Tata.